Hey everyone, in this video I want to show you how to graph a pineapple on Desmos. These next few videos we're going to stick with the 2D, the classic as I like to call it. To start with, I did some planning. I would like to make some variables that define the dimensions or the size of the pineapple, and one of them is going to dictate the roundness of it. So I'll show you how we're using these values. So this is the roundness, and there's also the height. So for now I'm gonna use zeros. These are default values. We can always change them. And the last variable I want to introduce is the radius. So can't use R because R implies something else on this calculator. And so I want to call it S. So our strategy here for making out this pineapple is we're going to start with a circle, slice in half, and drag it upwards. And for a circle, I'm going to start with two pieces here. So there's a square root of this is why I have this size, s squared minus x squared. And the reason we have the roundness here is two things. First, we can rewrite this square root as something to the 1/2 power, and that's why we have the roundness up here. And so as long as we keep this an even number, we can keep this round. If you put an odd number, it'll look weird. And so if you want to save ourselves some trouble, we can do is you can call this 1, but then down here just make it 2n. So now we make it 2. You're guaranteed even number because you're always doubling it. All right, and now we're going to move this by some height, and so let's make this 1. And if this is going to be the total gap between the top half and the bottom half, we should really be using half of this, so that for the bottom half here, this would be a minus, and then we subtract the height. So this gap is actually 1 unit in total. Now you can drag this out. Also make this bigger, so you can already start playing with the sliders. Next, we're going to identify points to close the gap here, and the way you're gonna find what these points are is gonna be based on what this here. So if this was squared, actually in fact, this is I believe this is just s here and minus s here. And so we did x equals, that's going to give us all the x values on, or no, all the y values on here. And so if we did s here, and then we go minus s, you see that now we have lines that are connected to. And now the next thing is to find out where the boundary points are. I'm going to close 1 so it's easier to see where it is. Earlier in this video I mentioned we want to cut our h value in half so that the gap in between is h units wide. And so for that reason, we're going to be bounding. It's better to start with the line that you can see here. So bottom is minus h over 2, and the top is h over 2. I want to unhide this other one here. Now what you're looking at here is going to be the body of the pineapple. The next piece we're going to graph is the leaves. And so let's make a new section for leaves. And I'm gonna start with the outside, the ones that point upwards. And we're gonna draw jagged lines in between and complete the lines here. So for the hyperbola, there's two kinds. So there's this version, minus y squared, and then there's also y squared minus x squared equals 1. And the one that we're going to grab is this one up here, because we want to take the top half of this hyperbola and connect it with jagged lines. So since we're starting with this one, let's solve for y. First thing, we're going to subtract x squared. Then we'll multiply across minus 1. So that'll give us x squared minus 1. And now we're just going to solve for the positive solution of y. So it's going to be the square root of this thing here. Now I'm going to decide how tall we want it. We can use variables, though, it's simply for time's sake. I like to not have to dynamically calculate what these points are relative to what these points are. So just for this segment, I'm going to be using hard set values. I want to take this bottom equation now since we're not using it, and then for some arbitrary reason, I'm just gonna pick. That looks like I want to go a little less than 2. Plus 1.8. All right. I like these lines to be a little closer together. At the same time, I do like how these bottom pieces are positioned, and so we're going to compress this x value, and so if we go. Yes. So we multiply the front. That'll compress the graph all together, but we don't want it to be that dramatic. And so 1.4 looks good to me, though you can always pick how much you want. And I want to start the jagged line around about here. Just for cleanliness, I'm going to steal this y value here. So this is, in the long term, we're gonna benefit better from the x value, because as we're gonna be coloring with those boundaries, and so I'm gonna be grabbing 1.0061. 1.0061 is, let's go to x positive 1.0061. And of course, we want to do the opposite. So we want x to be in between. That did read a little weird for a minute. That's why I took another look at it. Now for the jagged lines, let's see, the triangle wave, or as some have called the sawtooth wave, that is a sine inverse of sine of x. And we want this to be centered in the middle, and so cosine starts at cosine of 0 is 1. So if we want the better starting point, we should be using the cosine inverse instead. Right, the cheap fix here is by multiplying this whole thing by -1. I'm gonna color code this. And then we'll bring it up until it fits. So this line is way too wide and also way too tall. So first thing I'm going to do is I'm going to divide this by a number that looks a little better. And we want this to be more frequent. We're going to compress. We're going to multiply the inside x value. At least for what we're trying to do, that's fine. In fact, maybe I'll compress a little more so you can get these points here kind of inside. So let's just multiply that. I think we can stick with this and try not to be bogged down in details here. And then we can bring this down by just a smidge. That works. Alright, and then in terms of where they intersect, 1.5471. And now we can actually use these values to cut off the leaves here, at least the hyperbola. So this want to we want the negative value to end here, and for the positive value we're going to end that around here. And now all the lines that we have are in place. I like to do some initial coloring, and so let's make this green. And I want to start with this line down to this line here, because what that will reveal is the gap between this parabola here and this line here. And so let's start with the big one first. I'm going to say this line is the top, and this line here. So if you're unsure of which one's which, you click on the line here, and then I'll highlight this one here. And so I'll make a new section. We'll call it colors. Use quotes so that it won't try to get calculated. All right, and then for the boundaries, we're gonna. So what this exposed was how much overlap this had here, which is good. As now we want this to be the inner bounds of these two lines here. So the way we're going to pick this is we want the greater number of the left side and the small number of the right side. So that'll be this x value, and it'll be the positive version of this one. And so now you can see that if we're going to, now you can see how we're going to fill in these two gaps here. So since we're already on this line, I'm just going to grab it. Now note that this is the bottom line here, and so that's why we want this to be. That's why we're using a less than, and we're going to use the triangle wave again. And this time the boundaries is still going to be, actually for the boundaries we would be using we chose to cut this off here, so it'd be, if I can make it to the end here. Less than x, less than this number here. And then for the other side, it's going to be flipped. And so that would end at the positive version of this number here. Alright, now the good news is that coloring the main body is a lot easier. And so for that one, we're just going to grab the top half of this one. And I'm going to bound it with a bottom half, because these vertical lines in between, they're not really do anything in terms of what they're not going to influence the inequality. And so that's going to be a solid orange. So this is our initial coloring stage, and so that this looks more like a pineapple, I do want to draw the crosses. And so for the crosses, I'm still going to use the triangle wave, though if you wish, you can always use the straight lines. Thinking about this some more, I like to also use straight lines to graph the crosses. I want to make a gap, so that's going to decide how much spacing we want between each of the lines. And I want to show you on what that means. So I'm going to call this crosses, and we'll just start with y equals x, and the gap is going to be y equals x plus 0.2. Well, the gap size. So now you can see already if you're going to be happy with this. So I would like mine to be a little wider than that, and I like this better. You can, again, since you have control over this, you can always adjust this. And I'm going to draw a few more of these, and I think just for demonstration, I'm just going to draw one more pair on the top and do one pair on the bottom. Let's do y equals x plus 2g and x plus 3g. And then there's also the bottom half, x minus g. And so I like to start coloring in between, so let's actually start filling these in. I'm not going to go two phases on this where we go one line and then a shade in between. Instead, I'm just going to straight up go. Let's just start with this pairing. We go x is greater than y is greater than x plus g, and so that is easier to look at. It's gonna hide all of these guys here, and then the next gap is gonna be x plus 2g is greater than y is greater than and so we do the same thing on the bottom here. X minus g. This is the top equation. And what falls underneath it is x minus 2g. And it's the same process going the other way, so I'm not going to do all of it. I just want to do this purely for demonstration. And then we'll go the opposite. So it'd be minus x. In fact, I always think we could just copy this and just flip these around. Yes, what I'm going to do here. So for the next one, it's going to be everything minused. Okay, and then we'll start defining boundaries to cut these lines off. So to find the boundaries, we do find ourselves again in this situation where we need to draw this in 3 pieces, and so for starters, we do have. Let's start with the small number here, 1.282. And this ends, we want the less negative number, so the greater number here, minus 1.466. And I think you're beginning to see where this is going, where we do need to account for the curves that we have defined here. And so we do need, this time we want the bottom piece here, so that is x is less than or equal to y, and that's less than or equal to this top half here. And so that top half, I'm gonna find it, is this line here. And a boundary is gonna be 1.282, and I don't think we need to define the upper bound, because the upper bound is is where this domain ends. And then we need to do the same process for this other piece here. So that's going to be, so this top piece is x plus g, and we want this to be bounded by the bottom half, and so that's going to be minus of this minus that, and that we also have minus 1.466. I read that correctly? Yes. Okay, and that's going to be the greater value of all x's. I'm not going to do all of these lines on camera. That'll make the video far too long. And so what I'm instead going to do is I want to jump to the end and show you what your end result could look like. And it is really up to you to decide how many crosses you want to draw, if any. All right, so this is what I've chosen to end my pineapple at. And so I went 3 pairs one way and 3 pairs the other way. And so I do hope you've found this video helpful. If you did, do leave a like. If you do have questions on any of the processes shown, don't hesitate to ask them in the comments. And again, I do hope you benefited from this. If you did, do leave a like, and if you want to see more videos like this, do subscribe. And I'd like to thank you all for watching, and I will see you in the next video.